Yeah, so seeing as this is the day of it's due, and this is me at 6 o'clock in the morning, I hope you enjoy Heron's formula.
Say we have a triangle with side lengths 9, 11, and 16. How do we find the area of this triangle? To find its area, we can use Heron's formula, which gives that the area is equal to the square root of s times s minus a times s minus b times s minus c, where s is equal to a plus b plus c all over 2, and a, b, and c are the side lengths of a triangle. But you might be asking, how does this formula work? Where does this formula come from? And why does this formula work? In our example, we had a triangle with side lengths 9, 11, and 16. Let's go ahead and substitute our values for a, b, and c. Now we can start by calculating our value for s. We can start by substituting our value for a, and then we can just go ahead and substitute everything else. And we can do some arithmetic, and some more arithmetic, and we can store that s value for later. Now we can substitute our value for s and our sides. Now we can do some calculations, some simplifications, some more simplifications, and we arrive at our answer, 18 root 7. But that still leaves the question, where does this formula come from? So first I'll go over the proof for it. So we have our triangle with side lengths A, B, and C. Now we can construct the height. Now our base becomes two parts, a side length D and a side length of C minus D. From our triangle, we can get three equations. We know that the area of this triangle is base, C, times the height, h, divided by 2. From the left triangle, we can use Pythagorean theorem to find that d squared plus h squared is equal to a squared. And if we look at our right triangle, we can say that c minus d all squared plus h squared is equal to b squared. Now let's work with these three equations to find our area. Now we're trying to find the area, and we already know what c is, so we just need to find what h is. Now let's look at these two equations. First, let's subtract them. Note that the h scores cancel. Now we can factor the left side by using difference of squares. Distribute the negative, and note that the d scores cancel. Now let's isolate d on the left side.
Now that we have d, we can plug it into our original equation, find h, and plug it into our area formula. First, let's move d to the right side, factor by difference of squares, plug in what we have for d, combine the fractions. Now if we distribute the negative on the left side, rearrange some terms, we notice that on the right side, it becomes a perfect square, and on the left side, if we factor out a negative, that would also become a perfect square. Once we factor those, we can notice that we have squares on our powers again. We can factor once again by difference of squares. And boom, that's our h value. But that's not it. If we look at Heron's formula in yellow, and our area formula in white, even if we replace h with what we got, they don't look alike. Now let's use s to transform our equation into Heron's formula. Let's move the 1/2 c into our square root, and note that the c's cancel. Now let's split the parentheses and distribute our 4. This would become s. Now if we look at s, subtract an a, combine the fraction, and combine like terms, Note that our left parenthesis in our formula becomes s minus a. Now without having to bore you with the process, we can just say that without loss of generality, both our middle and right parentheses would become s minus c and s minus b, respectively. But where does this formula actually come from? Well, it comes from this guy, Heron of Alexandria. And it has to do with a triangle, and its in center, and respectively its in circle, creating tangents from the sides. We can note that the blue sides, the red sides, and the green sides each have its own equal value. Mathologer has a very good video about this that could explain it way better than I can. So this took me a lot longer expected. I hope you enjoyed all the work I did, and of course these are the credits. Thank you.